This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
The Center for Biomediated and Bioinspired Geotechnics, or CBBG for short, at Arizona State. Can you kind of talk about the relationship between you guys at the NHERI facility at UC Davis and that center? How do you guys work together?
Yeah, it's a fun one. So back in 2013 or so, there was the National Science Foundation put out a new call for proposals for engineering research centers. And engineering research centers by NSF are kind of they're a 10-year award for a conglomerate of universities to really make accelerated progress in a particular area. And it had been a long time since anyone in civil had one. And so Ed Kavazanjian out of Arizona State and myself, and then David Frost at Georgia Tech and Paolo Bandini at New Mexico State, we were involved in that process then of putting together a proposal and bidding, and eventually being fortunate to be one of the successful recipients of a grant back in 2015. And so we just began year 7 of the center. And so the network of those 4 universities together is focusing on accelerating this development of biomediated and bioinspired geotechs, the examples that we were talking about. In total, inside of that, there's a portfolio of about 20 some projects, 24 projects, maybe of different ideas. Some of those projects are linked and they're actually part of larger efforts, and some of them are trying new exploratory things that people have never tried before. Mm-hmm. And so in that's kind of the overall objective, but remembering NSF's mission of get to the field quick, get these things deployed, one of the things they require are test beds. And so test beds are platforms that are standardized to help people compare performances between different technologies and to get a glimpse about how will these technologies work in the field. And so, I mean, the Center for Geotechnical Modeling, right? The NHERI facility, perfect. And on top of that, we had already been up and running for decades, a couple of decades before NEAS, and then all of NEAS and NHERI. So there was nothing to build at that test bed because it was in place. The expertise is there. Ross and Dan are running it. We have the know-how. They're involved in CBBG and everything else. And so I was like, hey, this is perfect, because we need a facility, we need a capability like the centrifuge, the NHERI facility. We need that in order to get these biomedia and bioinspired technologies to try to help them accelerate to field deployment.
Wow. Yeah. I mean, because otherwise you'd have to, I couldn't even imagine building the centrifuge today. It would be
overwhelming.
Yeah,
for sure.
Many millions of dollars and probably impossible.
Yeah, it would be a big stretch. If we could do it, it would be cool, but it'd be a big stretch. And so we are very glad as the CBBG, putting that hat on, to have this facility already up and running. The other campuses have built out other facilities to help with this, mm-hmm. but have it be the centrifuge facility already be existing, already with NHERI funding, provided an unmatched really opportunity in terms of getting some early trials and some of the different technology. So that's been really, really useful.
That's great. You mentioned already that you've talked about some of these projects like this, the snake skin piles, and some things that you're working out with mimicking trees and things. Are there any other of those projects that you can talk about and how they're going?
Yeah, there is. There's a few. So on the biomediated side, we've certainly been doing this MICP, this cementation binding of what's behind you. We've been doing some of that in the centrifuge. And so actually, here's another photo. Why not? So there's a cemented block that was built in the large container. And then, so that was one zone which had a large cemented block. We placed foundations on it. Next to it, there's another one which has open space. And then there was smaller And then that was popped into the centrifuge, spun around, and then between spinning, then we have all these little small foundations models. Those are really tiny, right?
Oh,
But
yeah.
those are modeling kind of multimeter by multimeter individual foundation dimensions, and we can compare the performance of those things. So that was one. Another one that's biomediated is totally different. It's generating gas, and it's generating nitrogen gas in the ground. And the whole key of microbial induced desaturation, which is led by Ed Kevazanjian and Leon Van Passen at Arizona State, is the microbes generate gas. They generate the gas as small bubbles. It desaturates the soil, and when the water has become desaturated, as you have the gas bubbles inside of the pore space, it now becomes compressible. And if it becomes compressible, then you can't generate the pore pressure. So it's a different way to prevent liquefaction, not by strengthening the bonds of all the particles, but now changing the properties of the pore fluid space.
Wow.
And making it more compressible, so you cannot get the RU of one, the liquefaction, one of the liquefaction criteria. So they've done centrifuge testing. They've used the 1 meter centrifuge and built small models. They generate it at 1 G, and then they spin up, and that one's spinning at 80 G in the small centrifuge. And you have to wait because the gas bubbles and everything have to come into equilibrium.
Oh, yeah.
So you got to wait a little while, and then you can do your series of tests, and then you spin down. And the funny part is that on some of them, when we spun down a little bit fast, when you spin down, the release of stress because the G field's going down results in all the bubbles expanding, and you're looking at your model, and it's like it's burping. There's all these little these things popping in and out.
Yeah.
But nonetheless, the early tests on those also showed, the potential for success, which was important in their process for the MIDP, the desaturation work, to go to the field. So
that's great. And I think actually we have a previous interview about some of that field testing up in Oregon, around the Portland.
You got it.
Infrastructure.
Port of Portland.
Yeah, the Port of Portland.
Yeah, and that was in combination with Oregon State, right?
Yeah.
So yeah, exactly. So that field project was a follow-on of some of the centrifuge work that was done here, and we have similar kind of stories of trying to push stuff to the field on the cementation side. So those are two, I think, pretty interesting projects on the biomediated. And then on the bioinspired, there's one which is the snakeskin one, and Alejandro has tested that for static loading in compression and in tension, as well as cyclic loading up and down, kind of trying to simulate offshore, wave loading conditions and things like that.
Oh, yeah.
So
That's
maps
really
over to that.
important in offshore wind energy scenarios, which is a huge expanding market right now in the U.S. for sure.
Totally. So there's unique aspects for that. It's also been talked about in use in tunneling and use on geomembranes and use on a variety of other things. So that's the snakeskin part. And then the other one is we're actually just getting ready to do some testing on the small centrifuge with different root inspired kind of foundation or anchorage systems, and looking at shapes, which again aren't completely or identical to any natural root, but they take the critical elements in terms of its geometry, in terms of its shape, and put those into a more simplified form. And then those, and they're, at least early on, we're using 3D printed models, and then we're testing those at 1 G right now with a robot, and then we're testing them in the centrifuge coming up here. So those are some projects. There's a few more kind of in the queue, but by Paolo Bandini at NMSU and a few other people. So we kind of have this steady line of work and the steady demand from the center for the NHERI facility. So it's been a good match.
That's great. It kind of reminds me of another project that's went on at the NHERI facility at Oregon State, where they were looking at the effect of mangroves on tsunami and storm surge inundation. And by the nature of NHERI being a network, that's got a great opportunity for, hey, let's test this with the earthquake focus at UC Davis, and then maybe test that same structure and see how it does in terms of resisting storm surge at Oregon State.
Yeah, that's the neat that's one of the really enjoyable pieces about the Biomediated and Bioinspired Center, is that it's funded as an approach to developing new geotechnologies, and its application and what problem you're solving is actually quite varied, right? And so we have exactly what you're saying. We have people who need the centrifuge for the earthquake loading in particular. We also have other people in the team who are doing, mangrove erosion type of problems, and the tsunami, the wave basin at Oregon State is kind of a perfect candidate for that. And so there are different demands, if you will, hazard demands that different groups of people or different research teams within CBBG are taking a look at. And so it's again a nice combination between those, where we have technologies emerging from one group, and we have these established shared use national resources kind of provided through NHERI, and there's just a lot of things that align. It's really, really cool from that.
Thanks for listening to today's episode of Design Safe Radio. This show is sponsored by the National Science Foundation grant number 1612144. You can subscribe to Design Safe Radio on iTunes, Stitcher, or wherever you find your podcasts. Please leave us a review so we can improve the show. Please also help others find our episodes in iTunes. Thanks for your feedback and support. You can find out more about NHERI at designsafe-ci.org, on Facebook at Design Safe Radio, or on Twitter at NHERI Design Safe.